Hello everybody, my name is Anthony Sandoval and this is my final presentation on embedded microcontrollers for git335. Now, in order to start off this presentation, we need to ask ourselves, what exactly is a microcontroller? And what it essentially is just an integrated circuit made to control a specific function in an electrical or embedded system. As you can see, it only controls, unlike a CPU in a computer, it only controls one specific function in any device. And any microcontroller is comprised of certain parts such as a processor, amount of memory, or RAM, input-output peripherals, all on a single chip. Some peripherals that a microcontroller can have are an analog-digital converter, a digital-to-analog converter, a UART, and a temperature sensor. How a microcontroller works is by it interprets data through its input-output pins. Whatever is interpreted is stored, of course, just like any CPU, in RAM, and it uses whatever's stored in RAM to execute, whether it be like instructions, and it communicates with other hardware to send the appropriate response with the use of its input-output pins. All microcontrollers run at different clock speeds, and they all have a different amount of registers. Now, a register is a type of memory that can hold and send different types of data or instructions. Now, when thinking about microcontrollers, the first microcontroller was developed in 1971 by a man named Gary Boone. It was called the TMS-100. It was the first microcontroller that combined all essential components on a single chip: read-only memory, read-write memory, and a clock processor. Later on, with the stuff you learned about the TMS-100, the TMS-1000 was developed in 1974, and this was a series of microcontrollers that became to be the first commercially available microcontroller. When first introduced, the TMS-1000 only had 4 bits, but as time progressed, there's now microcontrollers with 8-bit and even 32-bit. New technologies such as flash memory allowed for microcontrollers to have memory that could be electrically replaced or reprogrammed so it can change and be altered. Having to reduce in size, microcontrollers can be found in almost anything you can think of, besides just calculators from Texas Instruments, from toothbrushes to game consoles to toys. Also, for the TMS-1000, that had only a clock speed of 400 kilohertz, while some, such as the ATmega, have a maximum speed of 20 megahertz. Also, microcontrollers from the beginning could only be programmed with archaic languages such as assembly language, but now microcontrollers can be programmed with a variety of different languages like C, Python, and even JavaScript. Now, when thinking, microcontrollers may sound similar to a microprocessor, but there is a difference. You see, with microcontrollers, they do not have an operating system like Windows 10 or Apple, or any operating system from Apple. Microprocessors are also mainly found in desktop computers and laptops, rather than household appliances like a coffee maker. Also, when anybody wants to build a PC or any type of computer, a microprocessor doesn't have a built-in RAM or read-only memory or any peripheral devices like a mouse or a laptop. Those all need to be bought separately and attached. Also, as mentioned earlier, microprocessors are only really used to enhance computer speed and functionality. Therefore, they require a lot more power and can tend to be more expensive than a microcontroller. Now, when thinking about microcontrollers, there's many different types across a multitude of brands. One such example is Intel. Intel is a well-known supplier of microcontrollers, as they created one of the most popular ones they created was the Intel 8051 in 1985, and it is still popular to this day, used in a variety of different devices and by hobbyists. Also, in 1996, Atmel developed the AVR, which is another one that's still used today. This one stands out from most microcontrollers, as it is the first microcontroller to utilize flash memory. Even here at ASU, the microcontrollers are used, such as the Atmega 328P. It is used in the class SER 486 taught here at ASU. Now, as mentioned, microcontrollers have many different uses, and they're used in many different devices, even cars, toys, household appliances, that was mentioned earlier. Also, besides just household appliances, they can also be programmed for industrial automation and factory use, and even robotics. Microcontrollers can also be combined with other devices to perform an IoT device, or Internet of Things, and that's essentially just a device that is able to send information to and retrieve to and from the Internet. Now, with microcontrollers, even though there's been incredible advances from 8-bit to 32-bit, from smaller clock speeds to higher clock speeds. Is there room for more development? Yes, there is. You see, even though the microcontroller, the Intel 8051, is still really popular, it's by today's technical standards, it's pretty antiquated. Only from 8-bit to 32-bit, 32-bit microcontrollers can process a lot more data when compared to 8-bit or even 16-bit, making them a lot more efficient. Also, 32-bit microcontrollers allow for the amount of power to be incredibly reduced, as they can run any applications at a much lower clock frequency or speed. For example, ARM-based microcontrollers come with a lot more registers and peripherals, meaning there's a lot more programming opportunities to make them do just about anything you can think of. Well, that's my presentation on embedded microcontrollers, and thank you.